Welcome back to another video, and today we are starting with arrays. So we'll start by what is array, what are arrays, and we'll look into array lists, we'll do some questions, we'll do some really nice things today. So let me just create a new structure, basically a new folder. I need to create a new project, and next. In community classroom, I can create lecture 8 or something in the lecture number 8. Arrays. So in this session, if you don't know what arrays are, we'll learn we'll dive into it from the basics, why we need arrays, what is the syntax, we'll see how we how can you store a roll number, so you can say, okay, if you want to store one name, I can just store it in a name variable. I can say it's saying that this reference variable is of an array. Similarly, R and O is a reference variable. Here I can say variable name is. So array is what I already mentioned. It's like a collection of data type. You cannot do something like this. You cannot do something like, okay, first two elements of my array will be integers. Second element will be a string. You can't do that. So this is point number 2 for people who are taking notes. Point number 2, all the type of the data in the array should be same. You cannot mix and match data types. Like, okay, first element will be integer, second will be float, third will be string, then again integer, then again boolean or whatever. No. If you are making an integer array, it will contain integers only. If you are making boolean array, it will contain boolean only. If you are making an array of string, it will contain string only. Okay, if you are making an array of some complex data type, like your own data type, which we will do in object-oriented programming, in that case, it will be of data type only. And where does that data type is defined? Where is it defined? It's defined over here. So this int bracket basically means RNOS, this reference variable, is pointing to an array object that contains type integer elements. Okay, so this thing is explained. How this is pointing to the memory and everything, I'll explain in a little bit. So why we need arrays, that thing is done. And what are arrays, that thing is done. Syntax is done. Okay, so one more thing I want to share in syntax is that how this thing is actually working. So basically, this reference variable is going to be pointing to this array object. So this right hand side thing that you have over here, it's the object and this is the reference variable. Let's dive into it. Let's open this up and look at every single thing in detail. So the thing that is happening over here is something like this. If I here, ROS is getting defined in the stack. Okay, it's just getting defined like, hey, there's a ROS reference variable. Currently, it's not pointing to anything. So we need to point it to an object. This is actual memory creation. Actually here, object is being created in the memory, heap memory. We already mentioned in the few sessions. If you want to see the complete DSA playlist, check out the links in the description. So basically, this is just the declaration and this is the initialization, basically. Talking about it, let's create a nice diagram and explain this. But this is the syntax to create an array. Things are working internally. Heap memory. Okay, so that is how this thing is working. Let's talk a little bit more about how it's working internally and how these things are actually being allocated, how the memory management works in Java. So I told you previously the things that are on the left hand side of equal to, that is at runtime. That's a shortcut to remember this. So this initialization and everything happens at this declaration and everything happens at runtime. Actual memory object, the actual object that is being created in the memory, the heap memory. And if you want to learn about heap memory, stack memory, we have a separate video on that already. That happens at runtime. So this happened as this thing happens at compile time, and this thing happens at runtime. Compile time, the actual object creating in the heap happens at runtime. So this is basically known as dynamic memory allocation. What is dynamic memory allocation? At the runtime, memory is allocated. That is dynamic memory allocation. Okay, this thing happens at compile time, this thing happens at runtime. Internally, it works something like this. So yeah, I already talked about like dynamic memory allocation. So assigning the memory space during the execution time or like the runtime. Internally, how does it think? How does it work? So basically, you have the stack memory in which all the function calls and reference variables go. ARR will go over here, and the actual array object, something like this: 3, 18, 9, 2. This will be pointing to this object. Okay, so this is the reference variable, and this is the object basically. Okay. Yep, it's recording. Cool. So whenever you want to get an item from the array, so when you say I want to get the first item, one thing you have to notice is that the array indices, if we talk about the indices, if this is like the stack memory, this is a heap memory. Okay, we talked about this in detail, heap memory, stack memory, JVM manages and all these things. I hope people who are regularly following the course, they are able to understand. Very simple stuff. We went into it in detail and we were doing the Java architecture. Okay, so array memory block, another memory block in your RAM or whatever, this is stored continuously in C++. Okay, so array is because in your cells like Java says something different. In Java, there is no concept of pointers. You cannot get the address or anything. So it totally depends on the JVM, whether this is going to be continuous or not. Okay, why? Because of this reason, we know, point number 1, we know that array objects are in heap. We know this because we know that objects are created in heap, not just array objects, all the other objects, also that we'll be making of like, let's say, object-oriented programming and stuff. We know that those will be stored in the heap section. So that is something we know. And the second thing we know is that if you check out the JLS, which is the Java language specification, where they have mentioned about the internals and workings of Java, in that they have specifically mentioned that heap objects are not continuous. Okay, there is no like confident proof of this, like it may continuous, maybe not continuous, whatever. They have mentioned that heap objects are not continuous. You know what continuous means now? Okay, it means that the cells memory are like one by one allocated, not like something is missing in between for the object. Okay, point number 2. Point number 2, we know that heap objects are not continuous. I believe you know what continuous is now. Continuous basically means it is your RAM, something like this. Continuous basically means if this array is allocated in C++, it means that it will be allocated for continuous blocks like this. It will not be like index number 1 lies here, another index lies here, another index lies somewhere over there. No, it will be continuous block of memory. But heap objects are not continuous. Java says that. Okay. And the heap is the runtime data area from which the memory for all the classes and instance of all the arrays is allocated. We also talked about this right now, dynamic memory allocation. When your program after compiling, so basically the declaration happens like at compile time, and when it's like actually creating the memory, actually assigning some memory, actually creating that array in the RAM or whatever object memory, that happens at runtime, dynamic memory allocation. Okay, point number 3. Point number 3, dynamic memory allocation. Okay, so heap area is not continuous, and we know that array objects are also in the heap area. Hence, array objects in Java may not be continuous. Okay, even though the definition of array says it's a continuous data. This is the definition of array if you Google it. But in Java, internally, may not be continuous. If someone asks you what might be the reason, this is the reason, and you can just answer them that it depends on JVM. Why does it depend on JVM? For people who are following the course, you will already know heap memory, stack memory, all these things are of JVM only. That is the reason it depends on JVM. All right. Cool. This thing is covered, and I also covered that one more thing I want to share is like the indices of arrays. So for example, if you have an array like this and you want to get the first item, so basically there is something called index of an array. What do we mean by index? Index are just numbers. That basically means it's like the position of the array which starts from 0. So it's going to start from 0. Next one is going to be 1, then 2, then 3, then 4, then 5, then 6. If there's a reference variable ARR that is pointing to this array, and you try to print something like ARR of 0. This basically means what element is at the 0th index of this array. It's going to print you 3. When you print something like ARR of 2, so it's going to print whatever is at the second index, which is 19. Talk more about this, the mutation of keyword 5. That is what new is. So here we have an object. Okay, new is used to create an object. Okay, new is used to create an object. So here if I'm saying new int dash brackets 5, it will create an object in the heap memory of array size 5. That is what new is. Okay, so this thing happens like, or you can do something. Initially, we talked about indices, so for elements, and by default, 0, 0, making a string. Okay, so this is a whatever. For example, we talked about is equal to some literal. If it's saying parseInt or whatever, you can see it's saying whatever, giving us errors basically. So it's just like a special type. It's like you can't reference it for like in primitives, but you can only assign it to non-primitives. It's just like a special literal that is like null value. You can compare it to with none in Python. Alright. Even if you're having more conceptions about Kunal what is null or whatever, then basically just it's in simple languages I can just share that any reference variable that you have, by default it's going to have the null type. So for example, this is a reference variable ROS, and it is not at this line, it's not a we'll talk about how this thing works internally. Basically here there are 4 objects, so we'll talk more about this internally and why this is showing null. I'll explain it to you in a little bit, why this thing is showing null, why every particular element of this is null. We will share about that in a minute. Of reference variables, as simple as it gets. Special value, literal, not an object or not a data type or whatever. Special value, that is the by default value of what reference variables point to. Let's dive into it. Let's dive into null and let's see why this by default everything is null over here. So internally what happens in Java is like, okay, you have primitives and whatever, that's fine. But what if you have an array of objects and not primitives? For example, if I have a string array, ARR is equal to new string, let's say 5 elements. Okay, internally what happens is internal working of object arrays, not primitives. Here you can see this is an object. We already talked about this, that primitives are actually, they are stored in the stack memory only, like int, char, bool or whatever. They are stored in the stack memory. Primitives. And for example, in the first lecture when we did like, so you have your stack memory into none. Reference variables when we are doing object will be like located, but let's say I'm saying integer AR, or if I can say anyway 2, 3 and 4, say 40 something. Yeah. What is that index number 3? 543. It's printing me 543. Internally, it's now stored something like this. Something like this. 23. Okay. To fill this one easy in that it's 4 for in the array class. We'll learn more about this in object-oriented programming. You can see it's a length variable which represents the length of the array. So here I can just say ARR of I is going to be equal to input. We can take an input. We can say scanner in is equal to new scanner system.in. So here I can say in dot next int. So whenever you take a next integer, it's going to be stored in the ARR of I. Initially the value will be 0. Then it will print, okay, ARR of 0 is equal to take the input. Then the value will be 1. ARR of 1 is equal to take the input. Then so on and so forth. Okay, that is pretty much about it. An enhanced for loop represents the comment as well. Okay, so basically this is the syntax for that. For data type reference variable in array, print that type. So basically here, I'll write it as a comment as well. Here num represents element of the array. So element number 1, element number 2, element number 3, 4. For every element in the array, print the element. For every element in array, print the element. That is what we're doing here. If I hide this, this is known as for each loop. Okay, if I type 5 numbers here, okay. Obviously, if you try to get the answer to more than 5 numbers, that will give you an array, an error. So basically, if you're saying print ARR of, let's say the last index is what? 0, 1, 2, 3, 4. So if you try to print ARR of 5, this will give you error. It's saying index out of bound. Index out of bound. The last index is index number 4 because the size is specified as 5. How are you printing size index 5? Index 5 does not exist. Error. So index out of bound error. Same thing if you write some negatives or whatever. Okay, cool. One more very nice way in order to print. So I showed you 2 ways to print. One easy way to print is actually do something like this. Print, there's an arrays class dot toString, and then you just pass the array over here. Array class has a toString method. When you give an array into it, it basically converts it into a string and prints that string. So you can see it's taking an integer array over here, and if the length is if the length is like, if the integer is array is empty, it's returning empty braces. If it's null, it's returning null. Otherwise, it's using string builder. String builder is something we'll talk more about in the later sections. And here just adding comma and everything, formatting it for us, and using a simple for loop, same thing that we were doing. Okay, if I try to run this, it will just without any for loop. Internally it's using for loop only. You can see internally it's using for loop only. Nothing new over here. Okay, I just write 5 numbers here like 1, 2, 3, 4, 5. It's printing. It's adding the brackets, adding comma and everything for us. That's true. Adding the brackets, adding the comma, adding the numbers and whatever. Okay, 3 ways to print, and this is the best one. Okay, this is very nice. Alrighty, cool. Now, if you want to learn more about, let's say we take a string array. Okay, we take a string array. We take an array of objects. This was like array of primitives. Okay, this is an array of primitives. Now we do array of objects. We already did this, like the string str is equal to something like new string name. Sorry, not name. What am I doing? Let's say 4 size. Okay, string arr. Sorry, not arr. Str. Okay, let me just hide this thing. The thing has been created in the heap, and by default, it's going to contain 4 objects in it because the size is 4, and by default, it's basically actually containing the reference variables to the objects. and those objects can be stored anywhere in the heap. I'll draw a diagram of this soon. One second. When I run this, let's say I just input 4 strings like A, B, C, D. A, B, C, and D. It's going to print A, B, C, D. Don't think that this is a character. This is a string. Okay, this can be a string as well. You want to do A, B, B, C, C, D, D. Internally, how it's being stored, let's look into it. So here you can see on the diagram, that is what is happening internally also. Basically, you have your, you have your stack memory and you have your heap memory. So in the stack memory, you have something like str in the stack memory, which is like pointing in the heap memory. Heap memory and actually contains a array of size 4. It's going to have 4 reference variables. Okay, some reference variables over here. There is some object AA over here, some object BB over here, some object CC over here, some object DD over here. This is pointing to this, this is pointing to this, this is pointing to this one, this is pointing to this one. It's storing reference variables to these objects. These objects can be anywhere in the heap. I hope that it is clear and it is very simple stuff, nothing dimensional array. Directly getting the reference, it's saying this is the reference variable, that thing, this thing, this thing, where that we have over here. Okay, this this first star that you see, this is actually str of 0. This is str of 1. Next one is str of 2. This variable directly over here and changing its value. Hence the original one will be changed. Very simple stuff. We have done something before also. Okay. If you initially just, you can see string 1 is changed to Kunal's original string object is changed. That is true. You're changing the original object. That is what we're doing. So you're doing something like this. You're saying that is what you're doing. What have we done? Call by making an integer array of, let's say, ARR or whatever, and saying the 0th index, change it to 99. Let's say I create an original index array over here, integer array. It's called nums. That takes something like 3, 4, 5, and 12 or whatever. I'm saying print this. So I'm saying print arrays dot toString nums. Obviously, it's going to print 3, 4, 5, 12. But after that, I'm saying change the value of the 0th index via this method. So just pass this nums array in the method. What is going to happen over here? Let's look at our diagram. Let us look at the diagram. What is going to happen over here? We have done this many times. You might be aware of it already now. So basically, initially we have something like 5 and name of the reference pointing to the isn't original one is also changed, right? Because both of these are pointing to the object. You can change the object. Look that into the 2, 7, 8, 9. So in this case, you are going to have 3 rows, 3 columns. How this works internally and everything will look later on, but let's first look into how we are defining this. So 1D array is defined like this with 1 bracket, 2D array is defined with 2 brackets. Okay, and I can say ARR is equal to new integer. I can pass a size over here. Let's say the number of rows that we are going to have is 3. Number of columns is not necessary to specify. Why? We will look into it shortly when we discuss how this is actually being stored in the memory. Then we will discuss about it. Adding the rows is mandatory. It's not like you are adding the columns only. No, this is not mandatory. The number of rows is mandatory. This is syntax. Here there you go number of rows. Here you add number of columns. You can definitely add number of columns as well, but it's not mandatory. Okay, cool. And if you want to store it like this, like in the hard way, we were doing it like directly. If you want to store something, so you can do something like this. Sorry, not this bracket, but like curly braces. You can store something like comma, 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 and then this 1, 2, 3, 4, 5, 6, 7, 8, 9. Things will be much more clear when we see how this thing is actually being stored in the memory. Without further ado, before we try input, output, before we try, the size and everything, whatever those things, let's see how this thing is working internally. Let's see. So in C, C++, this is also continuous memory allocation. Okay, even in 2D arrays, it's continuous memory allocation. In Java, it's something different. So in Java, it's saying if you have an array something like this, that is, it's pointing to an object, and internally it's stored something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's understand how this is being stored. Stack memory, heap memory. Understand how this is being stored. So basically, how is this being stored? Every single thing that you have over here in terms of the arrays. So basically, you can imagine this as meaning the 0th index is an array itself, the first index is an array itself, the second index is an array itself. Array of arrays. You can imagine it something like this. Okay, that is how it's like actually stored in the memory. In the memory, how it's stored in the heap section, basically it's stored something like this. So if you have array like this, stored in the heap memory, like this is the main array, that is the outside array. And internally, it has 3 internal arrays. This can be in some other part of the heap. This will be in some other part of the heap. This will be some other part of the heap. Same thing like we discussed previously. Individual ones are basically, just like the references to this individual array. So this will be individual array like 1, 2, 3. This will be individual array 4, 5, 6. This will be individual array 7, 8, 9. These are like going to be references to these arrays. Into it. Individual are of column size is not necessary, because how many number of arrays do you want to have? That thing should be there, because that way this has 3. Individual size of the number of rows is 3, number of arrays is 6, 7, 8, 9. Of 0, this will give me 6. Okay. So how do we input? We will run a for loop for every index. We will say, okay, first fill this particular array, then fill this particular array, then fill this particular array. We are doing the same thing that we were doing over here, input. This thing. We are saying, take this entire input. This is an input for one array. We need this thing, ARR, I can just hide it over here. I can make this ARR, for example. Okay. So this is something we need to do. So basically we need to 0th index in for every row. What is the length of the row, by the way? This is another important point. The length of the array, when you print the length of the array dot length, this will actually give me number of rows. So even if this was something like 3, 4, this will print me 3. Okay, good. So here I can just say 3, 2 for now. So here I can say ARR dot length, number of rows. And for every row, for each column in every row, I want to take the input. Again another for loop. This time for every column. I will explain this with the diagram as well. Don't worry. Column 0. This time column will be till where? This will be column. This will be having, let's say, size of 3. This will be having size of 2. This will be having size of 4. Even though in this case every column has a size of 2, but the size of the column is varying for every particular index of the array. Let's say the array at 0th index have a size of 3. Array of the first index have a size of 2. So here we are going to say every array at that index, every array at that row, the length of that array. Every array at that row, the length of that array. That is what we want. Okay, we will run this. Don't worry. I will completely run this. And then I can say ARR of row and column is equal to in dot next int. Okay, let's try to run this. Let's try to see how this is working internally. Let us try to see how this thing is working internally. Okay, let's try to run this. Let's try to see how this is working internally. Let us try to see how this thing is working internally. So we have two things over here. I am saying that initially it's a empty array of 3, 2. So basically 3, 2 means we have an empty array like this. Index 0, 1, 2, 0 and 1. These are my rows. What am I doing in the for loop? In the for loop is for every row. So we will say for every column starting from 0, column actually my row value is going to be 0. Then it's going to say okay, means array of 0, 0, take the input for that. I add something 23 over here. Then it will come out of this for loop. It will increment the column by 1. Then it's going to be like, is 1 less than 2? It's going to be like, yes it is. Okay, then 0, 1 should be another input. 0, 1 another input. Let's say 18. Value will be 2. Is 2 less than 2? Comma 0. Check. Is in column. Say okay. 33. So we already understood how to add 3 column. 0, column will be 0. Column is going to be less than size of the array of 0, 3. Where is the residual size thing? First. So I say I can input something like 1, 2, 3, 4, 5, 5, 6, 7, 8, 9. Basically it was taking just 3, 2, so it's taking 6 only, so that's 1, 2, 3, 4. Row number 2, because this is type of string fetching single video is 1, 2, 3. So that I know there are ARR of length number of rows. But how many columns are there? In the first one there are 4. So I can say for every column, what is this going to be less than? Is it going to be less than 4, 3, 2 or 1? Or what? No, it's actually going to be less than what is the size of that particular level. What is the size of that row? Size of the first row is going to be, or second we run for column report need. And taking data, we have to give a size. But what if you don't know how much size you need? What if you don't know that? What will you do then? You just want that, hey Java, please handle the size for me and let me input any number of elements that I want. If this is your problem statement, then you can use something known as an array list. If you have done C++, it is similar to vectors in C++. So array list is actually a part of the collection framework, which we'll do in more detail when we do like the object-oriented programming, and it's in the java.util.package. So basically, if I create array list example, basically when you don't know how much size you want, and we will also see how this is working internally. You might be having questions. Hey Kunal, how is it like that you're not specifying any size and it's doing automatically all these things and taking as many inputs as it likes? So get a syntax first. Syntax is basically like this: array list, data type, so it can be integer. Let's say I want to create an array list of integers. I can say list is equal to new object. So I'm creating a new object of this new array list. This is the syntax. You can also write the data type over here, but it's not mandatory. Similarly, for one more thing I wanted to share was in the integer type. For C people, you can do something like this as well. This is also valid, but it's not like the Java way to do it. This is much more clean. Okay, putting the braces after the variable name is also fine, but this is looking much more nicer. Okay, so in array list example, basically here, this is a syntax. Array list is a class. You can see here, it's a class because it starts with a capital letter. It extends abstraction. We will turn up in object-oriented programming. We'll look into what is extends. We'll look into what is implements. We will also look deep into what interfaces are and what is this list and what is this serial and whatever. Do not worry about it. For now, it is just a class. Just focus on that. Okay, so it's in the collection framework, and here I mentioned in the java.util you have the array list, and it's in the util package part of the collection framework. You can see over here. This class is a member of the Java collection framework. So there are list, linked list, and vector, whatever things that we are doing. They have provided these. So basically, what is collection framework in simple terms? In C++, you might have heard people say hey, with competitive programming, we have all these things defined already. We have all the data structures and everything written for us by some people already. We can just use this in competitive programming to make our things, make our lives easier. Similarly, there's a collection framework. All the other amazing data structures like linked list, stacks, like your what is it, hash maps, sets, and all these other things. Java provides the implementation for this in the collection framework. So we will be using collection framework. We will also be writing the entire data structure from scratch as well. When in the future we'll be doing data structures. Okay, that's the collection framework, and one of the classes that are a part of it is known as the array list class. Okay, so this is slower than the standard array. You can input anything you like, as many things as you want in it. If you want to give an initial, this is basically a constructor which we'll look more into when we do basically the object-oriented programming. So we'll look into constructor. Here you can pass the default size. I can say let's say 10. So initial capacity 10. Okay, for this, how this thing is working. So there are two things you might be confused with right now. First, let's look into how we can use this. Then we will look into how this is working internally. Kunal, how are you making sure that this will never be full? That we will also consider after this. Okay, so let's answer the first question first, how do we actually work with it? So basically, here when you're adding the type, okay, this has something to do with Java object-oriented programming with the interfaces and stuff and the generics. We have a generic as a separate, we have generics as a separate topic. So for now, just understand what we are doing. How we are doing it, we will do it in generics or in object-oriented programming. I know I say this a lot that we will do it in object-oriented programming. Trust me, if you see the syllabus, generics is available over there. So basically, generics is just saying what is the type of data that you can store in this list object. It's saying you can only store, let's say, integer. If I just write string over here, then you can store string over here. You can definitely not write it as well. It's totally fine. You can just skip this as well. That is not good practice. Okay, this is not good practice. Okay, good practice is actually write some data type that you're using. So here you cannot pass primitives. You have to pass the wrapper classes. We talked about wrapper classes already initially, but in detail we will talk about it in object-oriented programming. So it's like a wrapper class for the primitive data type int. Okay, so you cannot use the generic stuff like the specifying the type of the array list. You cannot use it like this. You cannot add primitives over here. You have to add wrapper classes. It has something to do with object-oriented programming. We will consider that later on. In the constructor is basically saying that all the initial values that you want to define specifically for this object, in that you can add it in a constructor. So this is basically a constructor being called. Forget about me saying constructor. Forget constructor from your mind. Don't worry about it. We will cover it in detail in object-oriented programming. For now, just imagine that a new object is being created of something like 67. Okay, I can add something like as many things that I want. I can do it again and again. I can say add something like this, add this, add this, add this, add this, whatever you want to add, as many things as you want to add. No initial size is specified. If you're saying, hey Kunal, you have specified 10 over here, okay, does not matter. Hey, look, add as many as you want. Let's try to print it. By the way, you can directly print list, because when we were doing arrays.toString, whenever you print a complex object, basically we will go in depth of toString as well. In object-oriented programming, I know I say this a lot, how toString is working, how these things are working, why am I doing toString? Not like whatever does not. 654. Does it contain 654? Yes, it does. It will give me true. True. If I write something that it does not contain, it will give me false. Okay, false. Other thing you can do is actually change some items. So I can say list dot update or whatever. Change or set, basically, yeah. List dot replace, I believe. I want to say set the zeroth index will be changed to 99. Let's print it over here. So you can update stuff as well. $99. So many things you can do. Okay, you can remove stuff from it as well. You can be something like, hey, let's say I want to remove the index number 2. So I can say remove index number 2 or whatever. What is index number 2? 654. 654 will be removed. Gone. Very simple stuff. Okay. Similarly, you can iterate upon it as well. You can say, if I take the input, it can be done now in the same way like we were doing previously. So you can say for I is equal to 0, I is less than, let's say 5, I plus plus. You can say list dot add something like in dot next int. I can create in, so I can say scanner out. We were doing previously. You have to do something like list dot get. Gonna add 5 items. Say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 print. So here you will pass the index. Okay. Pass index here. List of index syntax will not work here. Okay. Many things you can add in it. It will never be full. Let's see the array list things is working internally. So when in arrays we were talking about like list of references stuff. Like when you have an array of objects, it's actually we talked about this previously. If you have an array of object weighted, then you have like a array like this over here. In the stack you have the pointer and like this, like a reference. How is it saying that no size is required? You're providing, let's say, some initial size 10, but you are able to input 100, 1000 elements. How is that happening? Why is the size not fixed? In reality, in actual, this is what happens. Size is actually fixed. Okay? What will happen? This is what will happen. It will old elements had a size of element 1, 18 or whatever. When this is also half full, it will double the size of this again. We will go into details of this, why this is constant time complexity. Amortized time complexity, this means. Minimum capacity. That's true. You can see you're having some preferred capacity or whatever. This is also 3. It's going to take the array. It's going to take 2 indices. Let's 0 and 1. Or the 0 and the last index basically. Let's say 4. How am I going to print the maximum item? Let's say I just assume the end. Nothing here. So if basically you want to reverse an array, so how can you do it? So if you have then move here and end by -1. What is the end index going to be in the array? It's actually going to be array length -1. If the length of the array is 5, last index is 4. That is what we're doing over here. What is the condition for our while loop breaking? You know, even number arrays and odd number arrays as well. Let's I'm just not like the theory part. We did all the examples and everything we saw. Now the next thing is we're going to be doing some questions in a separate session. That session will be purely dedicated to or whatever. Start here, end here. Swap these two numbers. After that, it will be like 8 comma 1. Start will come over here. Start will come over here. End will come over here. So it will be like swap these two numbers. So this will be 9 and 5. End will come over here. Start will come over here. Basically, it's decrementing end by 1, incrementing start by 1. Our loop will end when start becomes greater than end. Now you can't swap it because start is now greater than end. And obviously this is done. This is my answer. Reverse of the array. Very simple stuff. Oh, notice you were not able to see. So let me just